Hello everyone, and once again welcome to another of my presentations on the Dash 8 Q400 aircraft that I fly. My name is Mohammed Adam. I'm a captain on Dash 8, and in today's little presentation I just wanted to go over a few concepts, just like two of them that have been brought to my attention, and maybe some people have actually asked. So in today's presentation, we will just want to talk in simple terms on a couple of things. One of them is basically what is the magic torque value to keep reference landing speed. And the word magic is what I've put in inverted commas, and there is a reason for that. And also another concept that I want to talk about is a very simple concept. It's how to keep a rate of descent of 600 to 800 foot per minute. Now the second part about the rate of descent in flight school and even in our normal everyday line flying, we normally know that we have to keep the glide slope centralized within 1 dot. Even if you are following a VNAV non-precision approach, we have to keep the VNAV bar at least centralized as well, and that automatically gives you on the vertical speed indicator a value of 600 to 800 foot per minute, which is a typical range for executing a non-precision or a precision approach. Somewhere around these values, 700 is what they call also a very good one, the best one, but 600 to 800 feet per minute is actually what is recommended. Now this value normally is scanned from the vertical speed indicator. That's what we normally do to get the numerical value that we are following, but often it becomes a bit hard to actually pick that value, which sometimes is very small, or maybe the needle and you are scanning other things and so many things are going on in the final approach. So what is your best reference? That's my aim for this presentation. What is your best reference to actually look at when you want to assure yourself that you are indeed following a rate of descent within these values? Okay, also depends on your configuration, of course, flap configuration. It depends on many other external factors like the wind strength and how heavy your aircraft is, and many other factors that determine this rate of descent. So we're going to talk briefly about that. I'm going to show you a video of my own flying, and I'm going to actually tell you where to look at to actually assure that you are actually following this rate of descent, and that that indicator that you have right in front of you is very big, is very obvious, it's right there and you can't miss it, unlike the vertical speed indicator needle or the digits that sometimes you can miss out and maybe exceed or reduce rate of descent. Okay, so the first thing what I wanted to tell you is that there are a couple of things I want us to make clear. First of all, there is no so-called magic values in aviation. I mean, the word magic is just basically used as a descriptive. Okay, there is nothing magic. Everything happens because it is designed or it is mathematically proven. All right, so magic is not a word to be taken in the literal sense. It is just a descriptive word, okay, just to make things look more interesting. But in reality, there is always a reason why some things we do, and as pilots we always have to have one question in our minds: why am I doing this? What is making me do this? That's a very important thing. Okay, so in that way you even advance your own professional growth. And every maneuver we do is by design of the aircraft, keeping limitations in mind, not exceeding manufacturer's limitation values and the like. So we respect limits is very important, because every design of every aircraft is subject to certain limitations which intentionally or even unintentionally we don't exceed in any regime of flight. That's very important. And the next thing is, which I wanted to even say, is what I've just said, that every numerical value, like let's say for example 3 degrees and rate of descents and the like, okay, airspeeds, altitudes, maximum certified altitudes, ceilings, performance, other performance limitations are all calculated using mathematical concepts, and they're not just pulled off the air and given to you in your manuals and you have to follow them. Okay, so from here onwards I'm going to now show you a video somebody on the jump seat was taking, and I'll be pausing the video here and there just to show you one or two things that you can be looking at in your next flying and see if it makes sense. Alright, so let's just now jump into that. Okay guys, so what you see on the screen here is a video which I'll take you through. I'll be pausing here and there just to show you exactly what we are trying to aim to explain. You can recall that I just mentioned that our first explanation is what is that magic, so-called magic torque value that we have to actually set in order to get a particular Vref for our landing. Vref meaning the landing speed. So I'm hoping you are able to see the cursor. The torque value appears on these torque gauges on the engine display. Right now the aircraft is on the final phase of the landing, on a final approach, and all the checks have been completed. I want you to pay a particular attention to this value here. Now some companies normally use hard copies to work out their takeoff weight, and takeoff speeds and landing weight, depending on what the performance of the aircraft dictates at a particular time. So one of the companies is the one I'm working for right now, is that we use a takeoff and landing distance takeoff and landing card is called TOLD card, which is like this one here, or it's also called a speed book. Okay, so as you can see that in our current configuration of this aircraft, our landing weight is 27,000 kilograms, 27 tons. Now when we are being taught, or we are being trained, normally some instructors will tell you exactly what we set to get our Vref, but many also on the same note will say that your torque values, which are appearing here on the torque indicators, should match the first 2 digits of the landing weight. So in our case here, if we have to set around 27%, it means that we are assured of keeping our landing speed within the Vref and Vref plus 10 limitation. Normally we don't go beyond Vref plus 10, but of course this happens if there are strong wind gusts and certain things that, you know, we can actually they are beyond our control, but we always try and control it, all right, so that we don't go beyond Vref plus 10 and we don't go below Vref. Okay, so if you look at this card here, for 27,000 kilograms, the landing speed with flaps 35, which is the landing flap in this configuration for this aircraft in this particular airport, is 118 knots. Okay, so we look at the 27,000 page, and then we look at the landing flap, which is 35, and then we see that with this weight we should be aiming at 118 knots. That's a Vref, but Vref plus 10 will be 128. So which means that your speed in the landing configuration should be between 118 and 128 knots. I hope that is making sense. So that's between Vref being 118 and Vref plus 10 being 128 knots. Okay, and in this particular configuration for this particular flight, for us to keep that figure or our indicated airspeed between those figures somewhere around there, we must maintain a torque of 27%. That's a rule. But now, why do we do that? That's the question. Okay, why is it that we have to match the torque value to the first two digits of a landing weight is what I'm trying to get to. So how we understand this whole concept is like this. If you use a full autopilot approach, there is a supplement 75, if I'm not mistaken. If we use supplement 75, where it says you use autopilot with flaps 35, okay, which has been done in this particular presentation, this video, and this flight, which I did, okay, you will note that for the autopilot to keep the pitch, the rate of descent, we have to actually apply a torque of around this value, 27%, but plus or minus 3. So around 28, 29, or maybe 26, 25, somewhere around there. Okay, somewhere around there you normally set your torque. Okay, but as you're coming right towards the landing, just near the threshold, then your torque value roughly matches this figure here, 27% in this case, all right, plus or minus 2%, somewhere around there. Okay, so now I'm answering the question, why is this so-called magic number set? It is not a magic number, it is what the aircraft actually does. And how do we know it? We know it if we keep the autopilot engaged, okay, until 1,000 feet AGL, all right, and once the flaps 35 is deployed with autopilot, the nose will start pitching down, as you can appreciate, because when you deploy flaps, you are increasing lift, but the aircraft wants to pitch down, so the autopilot says, no, I'm not going to go up, I'm going to pitch down. So the autopilot will pitch down quite significantly, but not that bad. It will pitch down, and then once the nose starts to rise up again, once the profile has been caught by the autopilot, the torque will have to be increased, because when the nose goes up, the speed bleeds. Okay, so we'll increase the torque. Now, when we actually maintain that same configuration with the autopilot and flaps 35, we will see that for us to maintain the Vref and Vref plus 10, or Vref plus 10, somewhere around there, the torque value which we set here roughly equals that value. So it's not a magic figure, as some people may call it. It is actually happening because the autopilot does this, or makes us do this when you are doing an autopilot approach. Okay, and before presenting to you this video, I have tried approaching with the autopilot engaged until 1,000 feet AGL and thereabouts, and I was studying which torque value here will give me the Vref I need. So for example, if I was coming in with 28 tons of landing weight, I will have here around 28% or around 29% or 27%. If I was coming with 26 tons, for example, somewhere here it will be 26%, 27%, somewhere around there. And that is all with the autopilot telling me that, look, for the aircraft, or for me, meaning the autopilot, to maintain this pitch and that speed, you must set that torque. Okay, now it is maybe a coincidence that it comes to us that the first two digits of the landing weight are actually our percentage for the torque values for the configuration of the aircraft. Okay, in the landing configuration with flaps 35. I hope that makes sense. So let's try and play the video, and I'll be stopping it as we go along just to show you what's happening. So right now what has been done is that we're about to deploy the flaps, and you'll see what happens. Okay, so you can see that the torque value is now coming up to around 25%. It has to, of course, match here, but it just happens because of sometimes there is a bit of a stagger, but normally we do correct this. We always are scanning our instruments. Apparently that day when I was flying this flight, it was very rainy. We only saw the runway at around 200 feet AGL actually, but the video wasn't showing the outside. It was normally aimed to show the inside and how the torque values and the like were coming up. Okay, so that's 1000 feet above ground level, and that was a 1000 feet call we had. And now I just want to pause here. I'm hoping you'll be able to see. If you see there's indication which is AP here, this is on the first officer side, the same on the captain's side, my side as well. It says autopilot. Can you see autopilot here? So with autopilot you can see that the speed is just around Vref. As you can see, it's around Vref here. So that's perfectly okay with autopilot. So the autopilot is saying that for us to maintain the Vref, we have to apply a torque of just around 27%. And the same thing here on my side as well. There is also the same. Now you can actually see that now I'm going to disengage the autopilot and I'm going to continue. So you can clearly see from here that this speed here is around 120. Okay, 120 you can actually see, and the autopilot is still engaged. So now you can see that this is what's happening. Now another thing I want to just touch on, because there were two presentations I want to make in this one. The other question was, how do you keep a rate of descent between 600 and 800 feet per minute? Okay, on the Dash 8 PFD, the vertical speed indicator is here, as you can see. All right, and the vertical speed is indicated right at the bottom here in decimals. All right, now sometimes being humans, most of the time we cannot always glance at this little value here. It's a bit difficult sometimes, but I want you to actually see the wing bars. If you can see the black wing bars here, which are right now overlapped obviously by the flight directors, but the moment we remove the flight directors, you'll see the black wing bars here. The rule is, if you keep the black wing bars between the horizon line and the negative 2.5 degree pitch line, the vertical scale here is in 2.5 degrees, so 2.5, then 5, and then 7.5, and so on and so forth. If you keep the wing bars between the horizon line and the 2.5 degree line for this particular configuration, so any particular configuration, you will be assured that the value here will be floating between somewhere around 600 to 800 feet per minute. This is a good indication. Now, if you compare how you're able to see the black wing bars, which are quite big in their appearance, and you can't miss them because your eyes are straight here, compared to the small digits that you see here, you will appreciate that the black wing bars are very good reference. So if you keep them floating between the horizon and just between the and the 2.5 degree, negative 2.5 degree line, right here where it is right now, if you keep the pitch somewhere there, you will be assured of the rate of descent to be appropriate. And you can clearly see right now the autopilot itself is making us keep, or is keeping, the pitch in between there. So we don't have to change anything. Unless something comes up, then definitely we can, but otherwise you can see that this is a good reference compared to having to scan the small digits, which some people can do with experience and more practice. You can actually even glance these numbers here, but this would be a very good visual cue that your rate of descent is exactly what it has to be for a particular approach. So we can unfreeze the video and let's see what's actually happening now. So now you can see the autopilot is a bit disengaged, and you can see the torque here. You can see it's around 28-30%. Okay, of course it will be equalized. Okay, it normally does happen because thrust levers sometimes have a bit of like a little asymmetry because of mechanical things, but I mean it's not an issue. And you can see that this value here, okay, for us to keep that Vref is matching 27 plus or minus 2 or 3%. That's what you have got to be aiming at. Okay, so now if we can see this, the autopilot has been disengaged now, and now you can clearly see that our torque values would be somewhere there. And now you can see I am trying to keep, now the autopilot is not there, I'm hand flying the aircraft, okay, and you can see that I will keep these black wing bars somewhere in between the horizon and the negative 2.5. So my eyes will be looking at this mostly because I'm assured that if I'm somewhere here, it means the rate of descent here will be around 600 to 800 feet per minute. I hope that is making sense. And even you can see my speed here is around 121, somewhere around there, 120 at least. Okay, it was quite a windy as well. You know, you can see quite a winds were just changing here and there because of all the weathers we had, but otherwise the winds were favoring exactly the runway which you're coming into. So the VREF is this marker here, this solid blue triangle, and that's 118 for this landing weight of 27 tons. And if I kept my torque like the way I was keeping, like the autopilot was keeping, and then when I took over, I didn't disturb the autopilot's setting which was given to me. I kept it just the way it was. That's how we set the torque, okay, based on the landing weight, the first 2 digits of landing weight, and that will make your VREF equal to VREF or VREF to VREF plus 10, somewhere here. I hope this idea is making sense to you, and also how to keep the pitch between 600 and 800 feet per minute by looking at the black wing bars to be between the horizon line and the negative 2.5 degree line. So let's continue and see how far we are getting. And otherwise, that's basically about it for this presentation. You can clearly see that here I had to drop a bit because, you know, there was a shear. The winds were picking up and dropping, so I had dropping a bit here and there, and then I was coming back up again. So it's always a constant adjustment. And then you can see this is what's happening. All right, so there we go. You see I've increased the torque there, so the speed was coming here. You can see blurrish images, but actually you can see that clearly the black wing bars are in between the the horizon 0 degrees line and the negative 2.5 degree line, and the VREF is almost, the speed is almost equal to VREF to VREF plus 10 just by that setting. Okay, it's always a constant battle in the final phases. You can see here, there we go, 26-27%, okay, on both engines, which is matching the landing weight. And this actually happens with all configurations. I've done, as I said, numerous flights after I wanted to find out why is it that the first 2 digits of the landing weight match the torque should match the torque value in order to give you the VREF to VREF plus 10. That was my main aim for this presentation, and I hope I have made it clear. It's been working out very well for me. It does work out for other people as well, so I'm pretty sure that this should be a good rule of thumb, we can call it. But we know now that it's the autopilot. If the autopilot commands us to keep this type of torque with flaps 35 in this case, to maintain our VREF to VREF plus 10, so we should do it as well, because what the aircraft's computer system is also demanding. Okay, so it's nothing magical, it's actually the autopilot. And you can see that we're coming there, and that's about it. So otherwise that's my presentation there, and I hope that you've understood why things are done in this way. Till the next time, and in the next video, next presentation, consider subscribing. It's going to be interesting. Consider sharing your comments as well, as most of you have been sharing, and then we'll make some more presentations. Whatever I come to learn, I will deliver, so that we share as aviators the knowledge. And of course, it would be nice to even know from most of you on your thoughts. Be safe always, as I keep saying in all my presentations. Safety comes first, and you guys all have happy landings. Until the next time, thank you.